Hey Math Models class. Today we're going to be looking at systems of equations. We should be on day 5. You're doing a great job. So there's 3 possible types of answers that you could come up with. So the first possible answer is probably the most common, and that's where we have a line and then another line, and they intersect at a point. This point right here is the solution. It's one solution. One solution. That's where they intersect. So one solution. Okay, and then when you find the coordinates of that point, you would write that point as a coordinate, as an ordered pair of that point right there. Okay, second possible answer you could come up with is no solution. This is where you have a line that does not intersect another line. So there's no intersection here. You may recall from geometry, these are known as parallel lines. And so if you get parallel lines, which means that their slopes of both of these lines are equal or are the same, you have no solution. Okay, the third type of solution that we could possibly come up with is called an infinite number of solutions. So we have a line, we graphed an equation of a line, and then we graphed another equation of a line, and it just happens to be the same line. And so they intersect at every single point. And since these lines go infinitely in both directions, there's an infinite number of solutions because they touch in an infinite number of points. Okay, so let's go ahead and move on to an example here. So let's look at this example. So first of all, notice that these equations are not in graphing format. Graphing format would be slope-intercept form. So we want to change these to slope-intercept form, and we did that last week. So this will be review. So we want to get y by itself, so we're going to cancel out the 3x by subtracting it. Notice that minus comes down on the y as a negative when this cancels out. The 0 is over here. That's our constant, but we do not have to write 0. You can if you want to. All right, now this is a -1 in front of the y and it's being multiplied, so we're going to divide everything by -1. And now we can graph this line. So our y-intercept is 0. And that's why it might be helpful to keep the 0 in the equation. Okay, our slope is 3 over 1. So we're going to, whoops, you know what? Is that right? It's hard to see here. Yeah, that's right. So 3, rise 3, 1, 2, 3, run 1. 1, 2, 3, run 1. 1, 2, 3, run 1. Then find yourself a straight edge. The more points you can plot, the straighter this line is going to be. So 3, 3, 3. Okay. All right, now we have to do this one. Let's do this one over here. So I'm going to rewrite it. It's going to be our constant. So we're going to move that x over. So we're going to cancel out a positive x with minus x. Again, that minus comes down on the y as a negative. The x term goes first, and then the minus 2. Then we're going to divide by that negative 1 out front. And now we're going to graph this line. Now notice a negative divided by a negative is a positive. And we don't have to keep the 1 underneath. Anything divided by 1 is itself. Same thing here. So we're going to start at 2 as our y-intercept. And our slope is 1 over 1. So we're going to rise 1, run 1. Rise 1, run 1. Well, that's as far as we need to go. We found our point of intersection right there. So our point of intersection is right here. It intersects at one point. So the solution is going to be one solution. It's going to be 1, 3. So the solution is 1, 3 right there. Okay, let's move along. Here's some more examples, and I'll be happy to do them for you if you need more. Just let me know, and I'll make more videos, okay? So I just want to move along here to algebraically. So let's start off with substitution. So with substitution, one of the two equations needs to be solved for a variable. So this equation right here is solved for x. Solved for x. And how do we know that? Because it's all by itself. Okay? So we don't have to do any work here. It's already solved for x. So what we're going to do is we're going to take this quantity, 3y plus 7, and we're going to replace x with 3y plus 7 right here. All right, so let's do that. So we got 4y plus 9 times, we're going to replace x with 3y plus 7 equals 1. Okay? Now, if we had solved for y, then we would replace y with this. Okay? So now we just need to solve this. So we're going to start off by distributing the 9, which is multiplication. Oh my goodness. Sometimes I write what I say. 9 times 3 is 27. And 9 times 7 is 63. All right, combining like terms, we get 31y. Now we just need to solve this equation for y, so we're going to undo the addition with subtraction. And divide by 31. So we get y equals, and we do this division, we get -2. So we're on our way. We know our solution has a y coordinate of -2. Now, we need the x coordinate. So we're going to take this answer, plug it back into this equation here, because this would be the most simplest one. So we have x equals 3, and we're going to replace y with -2 plus 7. So we get x equals, that's going to be -6 plus 7, x equals 1. And there's our solution. That's where these two lines intersect. All right. Now, next method, elimination. So to eliminate, what we want is we want the numbers to be the same in front of the variable. So 3 and 2, definitely not the same. 5 and -3, definitely not the same. So we have a problem. We want to make the numbers the same. So the simplest way is to multiply the top equation by this number here, 2. And then multiply the bottom equation by this number here, 3. So let's do that. So let's distribute the 2. This time we have to distribute it all the way across. So 6x plus 10y equals negative 8. All right, same thing here. We're going to distribute the 3. 6x, hey, that's what we wanted, minus 9y, and then equals 29 times 3, let's see, 9 times 3 is 27, carry the 2, 3 times 2 is 6, plus 2 is 8. All right, so when you're doing elimination, we want to make the numbers the same in front of the variable. It could be the x, or it could be the y, your choice. Now, to eliminate 6x, we're going to subtract because they're both positive and 6 minus 6 is 0. So that's going to eliminate. 10 minus negative 9. Remember, when you subtract a negative, it's the same as adding, so it's 10 plus 9. Negative 8 minus 87. You may want to use a calculator to do some of these. Remember, we're subtracting. So negative 8 minus 87 is going to be negative 95. Okay, divide by 19 on both sides. So now we need to divide. Negative 95 divided by 19 is going to be negative 5. So now we know that the y-coordinate is negative 5. Now to find the x-coordinate, we simply need to just plug this back into one of these two equations and solve for x. So let's move up here. I'm going to go ahead and do the top equation here. So 3x plus 5 times y, which we know is negative 5, equals negative 4. Solving for x, first we have to simplify. That's going to give us negative 25. Add 25 to cancel. 3x comes down, gives us 21. When we add those, divide by 3, x equals 7. And there's our solution. That's where these two equations intersect at that point. Now, if you have any struggles or you need to see another example, I'd be more than happy to do another video and send it to you. Just let me know.